All right, so homework 3, question 17. There will be something similar to this in the exam. So let's see, I'm actually going to, well, first I'll show you what it looks like, and then I will change to a whiteboard so I can do the work on it. So question 17, you have to build a tree. We're going to do, we are going to use the Hamming distances, which are just the count. In class, we did the P distance, which is the proportional distance, meaning we had to just not only count, but also account for the overall length of these sequences that we are comparing. For the Hamming distance, we're just going to do the count. And I think in the exam I decided for Hamming distance also, just to make it easier. And we are going to, whenever there are gaps, we're going to count the gaps as distances, meaning when you compare two sequences, if there's a gap in comparison to between the two of them, then that's a difference. All right, so we're going to build our distance matrix, and then we are going to make a tree. So those are the steps you need to do. And these are the sequences we are comparing. All right, so I'm going to go on the whiteboard and work on this there. All right, so the way you would do this, you would do an alignment. All right, so let's see. And don't worry, the alignment will be very short. You don't actually have to run. If you ran an alignment using a tool in these few sequences, I don't even know that you would get a result because it's too short. But here, I'm just going to like align them like this. Okay. And all right, I'm going to compare them. So those, it just looks like there's difference here. So there was some protein, a change here. These are all the same. And this T, I should line it up with this guy. So I want to change this one. I want to put a indel there and move it a little bit so it's lined up. I'm making my space a little better. Okay, so first step, you have to line them up, and then we can do the counts. Now we can do our matrix. So here's our distance matrix. We're going to have sequence 1 here, sequence 2 here, and sequence 3 here. And okay, 1, 2, need one more here, and 3. All right, so remember the distance matrix is this thing that is comparing the differences. And we are only doing the Hamming distance, so it's just the count. You don't have to count what's the total number of nucleotides. So, or in this case, amino acids. All right, when you compare, actually, let me do like this. When you compare sequence 1 to self, of course, it's the same thing. So I'm just going to put those minuses. They don't mean those, they just mean I don't need to compare those. And then we're going to compare sequence 1 with sequence 2. So 1 and 2, there is one difference here. Same. Okay, one difference. Sequence 1 and 2 have one difference. Sequence 1 and 3, so 1 and 3, I could even like move it like this, make it easier for myself. 1 and 3 have one difference. 2, remember we're counting the gap as a second different distance. So 1, 2, okay, just 2. So 2. And the last thing that we need to do is this one, is the 2 and 3. How about these guys? Oh, this guy's a mirror image of this part of the matrix. Okay, so 2 and 3. Move this guy down back here again. So same, one difference, and then everything else is the same. All right, 1. And now I'm like, good, I have my distance matrix here. I'm going to build my tree using UPGMA method. So my first step is I look at these numbers. Okay, then maybe I should write these guys either in different color. So this is the sequence number. That's not the number of distances. Sequence. I could have labeled them ABC, whatever. So now I'm going to look at these numbers here, and what I'm trying to find is what are my 2 most closely related sequences. So in this problem, what are the 2 most closely related sequences? Put it on the chat. So right now you're like, well, what you are looking for is good. So we don't know. Good, Daniel. So it's like, all right, how does he know that we don't know? What we're looking for here is what are the smallest numbers? Because since this is the distance matrix, these numbers are the dissimilarity. Now, where are they different? So with the 2 that are most closely related, they're least different from each other. So I'm looking for the smallest number. And it's like, oh, here, 1. That sounds like a small number. And like, oh, another 1. Then it's like, I don't know. Do you think that ever happens when you run computer programs to do this? Yes, it does. So do you guys remember that Clusto does 1 tree and just sticks with it, and then Muscle does 1 tree, and then scores that, and then builds another tree and scores that, and see which tree is better? So part of the reason why it does that is because of whenever it rebuilds this matrix, maybe one choice is better than the other. Right now, we don't know. So I'm going to make 2 different trees. And this is actually one of the options in the question, the homework. So right now, my lowest numbers are 1 and 1. So I just have to pick one of those 2. So in one of my trees, I'm going to say that the 2 most close related are sequence 1 and sequence 2. So this one is sequence 1, and this other guy is sequence 2. And for my other possibility of tree, I have this other one here, which is sequence 2 and sequence 3. So this other possible tree is sequence 2 and sequence 3. So these 2 are just 2 different possibilities. They are not the same tree that I'm building. And then I only have one more thing to do for each of these trees. So it will be like, all right, I have another sequence here and another sequence here. The order at which I draw this doesn't matter. I could have drawn it going the other way. Remember, it's like the same topology. So this guy here, I would have my sequence 3. And in this one, I have sequence 1. Now, for example, I wanted to calculate the length of this branch. So I also want you to calculate the length of this branch. And in UPGMA, this branch and this branch are the same length, because what we do is we take the distance between these 2 and it just split it in half. So the distance between sequence 1 and sequence 2 is 1. So the length of this node here, okay, so I'm going to do like a little scale here. This length here is that distance between sequence 1 and 2 split in half. So it's the average. So that's half. And then this length here will be the distance between sequence 3 and sequence 1 and 2. So I don't know if I asked this for this question, but for some other question I will. So what do you do? What's the distance between sequence 3 and sequence 1 and 2? You would rebuild this matrix, and what you would do is the distance between sequence 3 and sequence 1 and 2, because right now they're married. They're in this node here, and they don't exist separate entities. They agree on everything. So you're going to take the average between the distance of sequence 1 and 3 and the distance between sequence 3 and sequence 2. So the average of those, sequence 3 and sequence 1 is 2, and then sequence 3 and sequence 2 is 1. So 2 plus 1, 3. And then you split it in half. So it's going to be 1.5. So this guy here will be 1.5. And I will do the same procedure for the tree on the right. And which tree is more likely? At this point, we don't know. They're equally likely. So let me look at what options you had to answer, and then maybe we can do it together. So yeah, we'll do it here. Too many. All right. Okay, this should be, move it here. Okay, B, and let's do, okay, this is D, and let's do C here. Delete that. Won't let me do C. We'll look at this C from here. C. This one we don't need. This one doesn't need to go all the way here. And okay, so C. I guess that's C. And the last one, E. All right, that took some time to set up. Here we go. Okay, so let's do this together. Which ones are true? So UPGMA is an iterative tree building algorithm. True or false? Here, I'm going to do a poll. So yes is for true and no is for false. And then maybe why will you do that? I'm going to just put a reminder here on the top. So Clusto was something called progressive, and the muscle was iterative. Okay, and then maybe let me give you some more information. When we do EPGMA, we have to keep rebuilding this matrix every time we make this node. Then we now build a new matrix, which would look like this. I was lazy, I didn't do it, so let me do it here. So they're like, I don't understand. So this one will be our first matrix. And once you put the two entities in one node, so once you found the lowest number and you put them together in a node, now since they don't exist separate anymore, you have to draw another matrix. So I'm going to do it here. Your second version of the matrix would be, you have sequence 1 and 2 together, and sequence 3 is separate. And then here you would have, again, sequence 1 plus 2, and then here you have sequence 3. So you would fill this table out, and then that's how you end up with how long is this branch. So you would go sequence 1 and 2, they are the same to each other, and then the distance between sequence 3 and sequence 1 and 2 is the average of sequence 3 and sequence 1, sequence 3 and sequence 2. That information I get from this table. So sequence 3 and sequence 1 is 2, and then sequence 3 and sequence 2 is 1. So in here, I would have my 2 plus 1, and I would average it. All right, so that's how we end up with the number here, 1.5. So, and that's that node. Now, even though we have to keep rebuilding a new matrix every time we come up with a node, and then we have these things together, and now we need to compare that together with each individual until we run out of things to compare, as we did here. This is still not considered an iterative program. So the reason why I'm showing you this is because I think you're thinking, since there are so many iterations of this building the matrix, then it's an iterative program, but it's not. So you're supposed to say that UPGMA is progressive. So when we are doing this and then another matrix, we're progressing because we are now getting rid of individuals and then clustering them. So that one is not true. And let's see the next one, B. So next poll. So is B true? Let me see what is B saying. Come on, B, move. No. Okay, well, you have B from my homework. So B says the two most closely related sequences are sequence 1 and 2. And then I put the word necessarily there because you could say, yes, they are. But, okay, sequence 1 and 2, they are the two most closely related to each other. That would be true, except that for this problem, there is an alternative tree that at this point, since we didn't do any bootstrap, any statistics on this, as far as we know, it's equally likely. So the word necessarily that I put there was to basically make you choose no. Because this tree, can it be the true tree? Yeah, it can. But we could also make this tree. And we don't know which tree is better. So the answer to that would be no, because we don't actually know that sequence 1 and 2 are the most closely related. Maybe 2 and 3 are the two most closely related, because both of these trees are possibilities. All right, so hopefully you appreciate how in homework we take the questions to the next level. So C, UPGMA is progressive building. Okay, that one I alluded to it earlier, so let's see if you picked up on that. See, is that true or not? So I'm just going to show the answers because of time, but yeah, so it's progressive, it's not iterative. So when we are, the progressive part comes from the fact that we started a bunch and then we are trying to group them, and we are going through all these entities to try to group them in the nodes, but that's the progression of the algorithm. The iterative would mean that we build this tree, and then we also build this tree, and we compare both of them, and you see which one is best. But UPGMA, in the process that I showed you, we're building one and we're sticking with it. Doesn't matter it's the best one, it just means it's the first one. So let's see. And then the two different topologies are possible. So the question is basically asking if you understand that what the meaning of topology is. So D, is it true or not? All right, good job. You guys do understand what topology means. So yes, there are two different topologies possible for this. So good job. And then E, UPGMA is progressive. That was the first, you're welcome. That was like the first way of grouping things that people came up with. But then, as I said, then no, this is somebody's life work that they're like, let's refine these things. I don't like this multiple choice. I want to see which one is better. So there are people that they devote their lives to writing code, or to not only writing code, to figure out what is the most likely thing, because we don't actually know anything. These are all like our best guess. So the two most closely related trees sequences are sequences 2 and 3 necessarily. Okay, that's basically a repeat of the other question. So if you said no, you are right, because we don't know. Either 1 and 2 are the two most closely related, or 2 and 3 are the two most closely related. We don't know. We just know that there are two different topologies that are possible. And at this point, we didn't do any statistics, so we don't know which one is better. When we do muscle, it does statistics, and then the statistics will score this tree, and then we'll keep the best tree. And keeps doing that until the scores converge, and then it's like, there's no point in dating any other people. I'm just gonna marry this one. All right, so good with that question. If you have questions, I'll keep the whiteboard a little longer. If you don't have questions, I'm going to get rid of the whiteboard. All right, but with this is this, yeah, okay, I can do that. Which, yes, is in order. Okay, I'm going to get rid of the whiteboard, and I'm going to do 18 because that's the next one in order of questions. All right, buy a bunch of work. Actually, I'm going to take a picture of this screen because there's so much work. That one. So